Volcano on Mars. The first evidence is there. The largest volcano is 3 times the size of Mount Everest, and it's not even on Earth. It's on the red planet Mars. So what will happen if this volcano erupts? Is there any chance that it will erupt? Welcome back to Volcanow. If you're new here, subscribe to the channel and press the like button. With that note, let's get started. The red planet may still be volcanically active, boosting the potential that it was once habitable, according to the evidence from what may be the youngest eruption ever observed on Mars, new research concludes. The majority of Mars's volcanic activity took place between 3 billion and 4 billion years ago, leaving behind enormous structures like the Olympus Mons, the solar system's largest mountain. Olympus Mons is about 3 times as tall as Mount Everest, which is the highest mountain on Earth at 16 miles high or 25 kilometers high. The largest volcano on Mars, the Olympus Mons, originated during the Hesperian period, with eruptions continuing long into the Amazonian period. It's the youngest of the planet's big volcanoes. Since the late 19th century, astronomers have been aware of it as the albedo feature Nix Olympica. Long before satellite probes verified it to be a mountain, it was assumed to be mountainous. The volcano is situated in the western hemisphere of Mars, with its center at 18 degrees 39 N, 226 degrees 12 E, not far from the Tharsis Bulge's northern edge. The volcano's central and eastern portions are located in the adjacent Tharsis Quadrangle, whilst the western portion is located in the Amazonis Quadrangle. Olympus Mons has a fairly gentle sloping contour due to its status as a shield volcano. The volcano's flanks only have an average slope of 5%. The flanks have a concave upward contour because the slopes are highest at the middle of the flanks and become shallower towards the base. In comparison to the southeast, its flanks are shallower and reach farther to the northwestern side of the summit. The volcano's profile and shape have been compared to a circus tent supported by a single off-center pole. Olympus Mons is large and has shallow slopes, making it impossible for someone standing on the Martian surface to see the full volcano's profile even from a vast distance. Such a synoptic perspective would be obstructed by the planet's curvature and the volcano itself. The slope of the volcano would reach far beyond the horizon, just 3 kilometers distant, so that an observer near the peak would not be aware that they were standing on an extremely high mountain. At the summit of Olympus Mons, the usual atmospheric pressure is 72 pascals, or roughly 12% of the ordinary 600 pascals of the Martian surface. Both values are extremely low by terrestrial standards. For instance, Mount Everest's summit atmospheric pressure is 32,000 pascals, or around 32% of the pressure at sea level on Earth. Even so, airborne Martian dust is still there, and high-altitude orographic clouds frequently drift over the peak of Mount Olympus Mons. Since Mars has far lower gravity than on Earth, even though the average surface atmospheric temperature on Mars is only 1% of Earth's, the atmosphere on Mars is more expansive. It doesn't lose density with height as abruptly as Earth does. Olympus Mons is made up of about 44% silicates, 17.5% iron oxides, which are responsible for the planet's red color, 7% aluminium, 6% magnesium, 6% calcium, and very high quantities of sulfur dioxide at 7%. These findings suggest that basalts and other mafic rocks make up the majority of the surface. These materials would have erupted as low viscosity lava flows, which would have produced the planet's flat surface. Now the real question is the largest volcano in the entire solar system still active? Previous studies have revealed that as nearly as 2.5 million years ago, the red planet may have flared with minor volcanic explosions. Now, researchers have discovered evidence that Mars may still be experiencing volcanic activity, including traces of an eruption that occurred about 50,000 years ago. Quote, "This being the youngest documented volcanic eruption on Mars, the potential that Mars could potentially be volcanically active at present is exciting." End quote. David Horvath, a planetary scientist currently working at the Planetary Science Institution in Tucson, Arizona, is the study's primary author. Researchers examined the largely featureless equatorial plains of the Elysium Planitia region using information from satellites orbiting Mars. They found a previously unidentified smooth, dark volcanic deposit that was roughly 8 miles or 13 kilometers wide and slightly bigger than Washington, D.C. It surrounds one of the fissures of the Cerberus Fossae fissure system, a volcanic fissure that is about 20 miles wide or 32 kilometers wide. Quote, "I first noticed this volcanic deposit when I was looking over some images of this region. I had looked at this area many times before, but somehow always overlooked this feature." End quote. Planetary scientist Jeff Andrews Hanna, the study's senior author, works at the University of Arizona in Tucson. Quote, "Once this odd dark deposit centered on a volcanic fissure came to my attention, I knew it was telling us something important." End quote. According to Andrews Hanna, this deposit specifically was unlike anything else that she had seen in the area or even on all of Mars. It was more akin to characteristics left over from earlier volcanic eruptions on the Moon and Mercury. Lava streaming across the surface, akin to the recent eruptions in Iceland, was the predominant kind of volcanism previously observed in Elysium Planitia and other regions of Mars. The researchers discovered the eruption's material qualities, content, and distribution matched what they would anticipate from a pyroclastic eruption, which is an explosive magma outburst powered by expanding gases similar to the popping of a shaken soda can. Quote, "This eruption could have spewed ash as high as 10 kilometers or 6 miles into the Martian atmosphere." End quote. Horvath said this in a statement. Though there are several instances of intense volcanism on Mars, those happened in the distant past. It's likely that these pyroclastic deposits were previously more prevalent, but the majority have since eroded or been buried, according to Horvath. Nearly 1,600 kilometers or 1,000 miles separate the newly discovered volcanic deposit from NASA's InSight lander, which has been studying tectonic activity on Mars since 2018. These new discoveries suggest that recent volcanic activity may have heated the red planet, making it more hospitable to life as we know it. Ice near the surface may have melted due to the magma coming up from deep down, creating optimal circumstances for microbial life very recently. Well, there are more mysteries than answers, but we know for a fact that this volcano isn't erupting. At least not anytime soon. I can't take responsibility for any act of higher power, so it's fair to say it beforehand. So what are your thoughts about this? Why don't you tell us in the comment section below? Thank you so much for watching Volcanow. Don't forget to subscribe, like, and turn on the bell icon for more notifications about upcoming videos. Make sure to check out similar videos from our channel, and I'll see you in the next one.